Okay, let's prove by contradiction that there are infinitely many prime numbers. Well, let's assume there is or there exists a finite number of primes, okay? Let's call this number, we're going to list them out. So prime 1, prime 2, prime 3, we'll go all the way to our finite number of n. Okay, we're going to consider a number where we multiply all these we're going to multiply all these prime numbers. Prime 1 times prime 2 times prime 3 times, I'm going to go all the way to that last prime number. But now we're going to plus 1 to this number. So what this means is when I take this number and we divide it, I can divide it by prime 1, we're going to get a remainder 1. If I take the number and I divide it by any of the prime numbers that we have, we're always going to have a remainder. So what it means is none of the prime numbers will divide into this number without leaving a remainder. So every number will leave a remainder 1. So what this means is either our new number n, which I've got here, it either has to be a new prime number or has a prime factor which is not listed in our above list, or has a prime factor not listed above. Therefore, this is a contradiction to our list of finite prime numbers, and therefore there must be an infinite number of prime numbers. And there we are, that's our proof. So, just a recap, we begin by assuming the original statement is false. We've listed out all the prime numbers that exist. We've made a new number, which is one more than the product of all the prime numbers that we've listed. We've contradicted the assumption that the list, we've contradicted it here with this statement that this list contains every prime number possible. Therefore, we've concluded the proof by stating that the original statement must be true, that there are infinitely many prime numbers, and we're done.